Okay, go ahead and share now.
Yeah.
Okie doke, and there we go. Can you see the screen?
Yep.
Looks good.
Okay. Well, okay, here's my talk. It's enticingly called HelioCloud Update. I'm not sure I came up with this title, or maybe I was assigned this title, but that's okay. I'm going to make it work either way. So HelioCloud is a project that certainly I am not the sole author of, far from it. I just want to make a quick shout out to the current HelioCloud team. And folks are working both at NASA Goddard and at APL to carry out this vision. So what is it that I'm going to actually talk about here in this presentation? I'd like to sort of outline three main things. First, give an introduction to what it is, the vision and sort of the main realization of it at this point. Then I want to, because the title says update, I will proceed to provide an overview of the progress, what's been accomplished and where we're going. And then I think I would be remiss if I didn't take advantage of the fact that I have a PyHC community crowd here to pull on a few things where both HelioCloud and PyHC have overlapping interests. And I'll get to that. So if you're like me, and when you get a new book or whatever, you just skip to the end to look at the conclusion, you can cheat just as easily and go to that little tiny URL at the bottom. It appears in all the slides, and that's where the deck is. All right, moving on. So what is HelioCloud? Our vision here is to create an environment where researchers distributed wherever, anywhere in the world really, can co-discover, share, publish, collaborate, and work with very large collections of research artifacts. And by research artifact, we don't mean just data or data files. They may be software, it might be realizations of software such as notebooks or compiled binaries, it could be containers, it could be other things that we haven't even thought of yet. Basically, a research artifact is anything which is the ephemera or the result or the input to heliophysics research, if you will. So that also includes the research paper as well. So that sounds like a pretty tall order. It is, but we're up for the challenge. And how we're going to do that is to create a distributed, in terms of spreading it around the world, computing framework for heliophysics. And that word distributed computing framework phrase, sorry, not a word, but that phrase packs a lot of stuff into it. So breaking that down, the characteristics of that framework, or the HelioCloud for short, is that first of all, it comprises an extensible base software stack for heliophysics research. It is a framework itself of complementary components for heliophysics research. These components are services or libraries or functionality that researchers can directly make use of. And its outcome is that the research artifacts are shared, users and institutions. So the research artifacts are shared publicly, if you will. You can just freely grab them from wherever they're hosted. But users and institutions then cover the compute costs, and whether that's locally on their laptop or in their institutional cloud environment. They are covering that compute cost. It's not something that NASA is defraying or other institutions are. You cover your own, you bring your compute to the data effectively. And that last thing, cloud deployed, is what allows you to bring your compute to the data so that we can effectively tackle challenging problems in heliophysics research now, particularly with large or big data. So what would this cloud platform framework look like? So at a very high level, what we're looking at is essentially an environment. The purple boxes would be the institutional deployment. So two or more institutions are deploying HelioCloud into their cloud environment. And they have a buffet menu, if you will, of choices that they can make. You don't have to deploy all the major components, as are shown here in the little sub boxes, but you can choose one or more, and you can safely say that you've deployed HelioCloud. So based on your needs, your desires, you could deploy the Dask Hub, which I'll explain in a little bit. You could deploy a storage component, which also includes a registry of data that allows it to broadcast, publish, if you will, to other Helio Cloud instances, the existence of data in the cloud. It may involve a dashboard, which we've worked on, that allows you to give your users the ability, a limited but still powerful ability to bring up VMs within your cloud environment without wrecking the environment for the rest of the users in that shared environment. Or it may involve some kind of software development support. Here we talk about things like CI/CD or Binder Hub, which allows you to register and share notebooks with compute associated with it, or maybe a container registry, all sitting in that blue box there. So all of these things are optional. I don't really stress that. It's not that you have to take it all or nothing. It's exactly the opposite of that. So if there's one thing in here that you find compelling, then you can pick it up and utilize it. There's another aspect of this, is that it's not always deployable in the cloud. It's not always have to be deployed in the cloud. There's goodness here in terms of just the software stack. And that is that we've spent some effort to engineer a virtual software environment, essentially a requirements.txt file. I'm going to assume that most people here are software knowledgeable, and I know that I've seen some names on here are experts in Python development. So if I skip over some what I think are obvious things, please stop and raise a question. But basically, a virtual software environment allows you to say this software project has associated with it a software environment, and it's a unique environment that works for this project. And I can have multiple virtual software environments on my laptop, because I could have multiple software development projects, right? And they all may have different requirement needs, and I don't want them to step over each other or cause what is known in colloquially in the business as dependency hell, where I try to engineer two projects together. But this is precisely what we have done. So we've done the heavy lifting, working with the community and the PyHC community to make sure that the PyHC packages all work and play together well within the virtual software environment, which we can then distribute. And that's the basis for the Helio Cloud software stack, is this virtual environment, and it's a conda and pip file and requirements file together, because we can't use just conda. And you can deploy that on any machine. You can put it on your laptop, or you can put it on a friend's laptop. You can give it to them so that they can deploy it. And it's sort of a base entitlement, if you will, for trying to share software across machines. There is more and better, though, or higher up the food chain, if you will. We can then build that software environment into a container that we might distribute. And so that's sort of bundling the OS goodness with the virtual software environment. And then the container solves the didn't compile for me problem, because maybe you don't have access to a certain version of Python that virtual software environment requires, but you could build it into the container. And then the container is available for you, and you can run it via Docker, which is a typical containerized technology. There are others like Singularity, but what is most commonly found out there now is Docker-based technology. And then finally, if you're a researcher, and there are many out there that really aren't into the software development side of things, not particularly good at it, and just want to get on to the research, then we could deploy the container into the cloud so that it's backing a service such as something we call Dask Hub that is available just directly through the browser. So every time you go in and open up a session and then open up a notebook or whatnot, it's backed by this container, or if you open a terminal, then the virtual software environment is there and it's up as the default environment and working. And so things just quote unquote work, and you don't have to do a whole lot of lifting. And these things are extensible, right? If you find that the basic virtual environment doesn't have a library you want, you're free to add another one, or to change the versions of it. But it's basically sort of sitting there on the shelf, ready to go as a basic entitlement, a basic starting point for you to work on your software. So what have we done? Let's start with sort of the past year here and our accomplishments. One of the big ones is just getting this Dask Hub up and running. The Dask Hub is effectively a Jupyter Lab environment. So we certainly didn't develop this whole cloth or anything like that. We're taking off the shelf functionality that's out there. the Jupyter Lab project. And in fact, DaskHub is a sub-project built on Jupyter Lab from Pangeo. And what we've done is we've swapped out, if you don't know about Pangeo, it's effective, it's a project very similar to PanHelio. It predates it really. It's the inspiration for PanHelio, for Helio Cloud, I should say. And it's for the earth science community. So what we've done is essentially swap out the earth science software, which we generally don't use or are interested in, and inserted the PyHC core packages along with many other PyHC projects and software that we understand from working with users, researchers in heliophysics, that they want to have to support their Python-based heliophysics research. And so that's essentially the Helio Cloud virtual software stack. And it just runs in this DaskHub. A feature of the DaskHub is that it does bursting. Burstable compute means that when you're running a session in the DaskHub, you can essentially make a call to the Dask library, which will then spin up virtual machines for you so that you can do highly parallel jobs and do very efficient computing in that fashion for those types of algorithms, software that are amenable to it. And you can process quite a bit of data. For example, I've demonstrated using DaskHub to process and crank through several terabytes of data in minutes, and that's very nice. A thing that we've been working on, initially trying to deploy DaskHub, picking up the Pangeo wrappers and deployment scripts and trying to get them to work was a minor nightmare, let's say. And we've spent quite a bit of effort to facilitate making that easier to deploy so that this is an easier thing for others to deploy at their institution. Another component that we've spent some time working on in the last year is this dashboard, or going to be rebranded to user portal. And this is a thing that allows, DaskHub isn't always the answer, right? We view these things sort of like as golf clubs. You're on the golf course and you don't use a driver to put in to the hole. Same thing here. The research project maybe doesn't necessarily fit in the context of DaskHub. Maybe you need to have a separate standalone VM. And so the dashboard scratches that itch and allows users to start, stop, terminate, and work with it, also to track their spending if that's important to the institution that's hosting it. And it really is about the AWS console, where all of this is based currently, is an extremely complex beast, and it's the last thing that you want to expose to your users, in part because it's confusing and there's a somewhat steep learning curve to using it, but also because it's dangerous, right? Multiple users on the same AWS account who really don't know what they're doing. No, nothing can go wrong there, right? People deleting other people's machines and whatnot. So this is what this user portal does, is it mediates the interaction with the AWS account, giving enough permissions for people to do the stuff they want to do, but not allowing them to do things like foobar other people's environments. And then finally, a big win for us was being involved in the PyHC Summer School, where we provided the environment for running the tutorials and the teaching session. And we demonstrated that this environment was robust and ready to handle many users. At one point, we stress tested it up to 500 simultaneous users. But of course, that's with automated scripts, and you never know exactly how much it can handle. So the real test was to actually have real users on there. And we averaged about 80 simultaneous users throughout 5 days with very few hiccups. I'm not going to say there were none, but it typically involved the spinning up the new machines. As we got a lot of demand, people had to wait a few minutes to get their virtual session. But other than that, it worked more or less flawlessly, I think is fair to say. And we also demonstrated up to a peak of, I think, 130, 140 users on the first day simultaneously using the environment. And of course, a very positive outcome of this is this was a very strong driver for us to sit down and roll up sleeves and do all of the engineering to resolve the dependencies that were in conflict with one another for PyHC core packages. So that was our big driver there. Looking to the next year, and I hope this is not confusing, but on the NASA Helio Cloud instance, we're aggressively uploading data. So we want to get to, it's one thing to have access to burstable compute, but if there's no data there and you have to bring the data, you're not really bringing compute to data are you? Because there's no data to bring the compute to. So really one of the really key things that we have to do here is get lots of data into the cloud. And that's what we're pushing on. We're putting a lot of mission data up in, focusing on SPDF or space physics level 2 data. So we'll have the entire SPDF level 2 in the cloud, and the STAC, our solar repo, will have selected data focusing on SDO, stereo. I think Iris is going in, and whatnot. And then, of course, we're also going to co-host some contributed research data. We've just posted one for SDO ML dataset from the JSOC Stanford. And all of this will be searchable so that you can find the data files that you want to bring your compute to. Another objective for the next year is to really knuckle down and facilitate the Helio to Helio Cloud conversation, those green arrows in the diagram down there. You know, being able to ensure that when a new Helio Cloud instance is brought up at some other institution, that it will talk and immediately self-register or talk to the others and say, hey, I'm here, I exist. What data do you have? What research artifacts do you have? Hey, look, I've got these research artifacts. Basically that kind of conversation, if I can classify it that way. We're also looking to, you know, as part of that, build out some of the components that we don't currently have, such as the binder hub. And we're looking forward to working with international partners in collaborating via the IDEA consortium, and also working to organize a cloud computing workshop for heliophysics sometime in spring 2023. Unfortunately, I don't have a hard date, and we're just at the beginning of our planning, but stay tuned for more later on that. And of course, even more capabilities that we're looking at, making sure that machine learning works pretty well within the environment. It's not super well supported at this point. Working aggressively to get GPU accelerated DAS jobs up and going, support in the dashboard for S3 buckets, and so forth and so on. So let's get to the meat of this. So there's a big windup for what I hope is a discussion, at least a little bit here. I just want to point out that the Helio Cloud project and PyHC really do have some shared interests. It's not just, you know, the occasional summer school jam that we have an overlap in, but really, if I could lay it out as 3 main points here, I think we're all invested in or should be invested in wanting to make this software work well together. You know, people don't just use PySpeedas. Well, I guess maybe some do. People don't just use SunPy. People don't just use SolarMach. People don't just use blah, 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 right? They tend to use one or more things, at least over time and possibly in the same project. And maybe they're not using these things in the same project, not only because of awareness, but because they don't work well together because of dependency conflicts. We really want to avoid that. It's certainly a requirement for us in Helio Cloud, because we can't deliver on our vision and promise that it's sort of transparent, low impedance heliophysics research if people have to go through dependency hell to make their software work in the cloud, which is, you know, everybody's going to be doing that. So we might as well just take care of business up front. So we all, I think, are invested in wanting to make it easy for our users to both access and use this software. So not only just the dependency part, but also hosting tutorials, distributing the knowledge. You know, Helio Cloud can help to some extent in terms of particularly publishing notebooks and making them aware of other users. So if somebody does something cool on one instance and one team and they want to share it, they can make that available so they don't have to go through a formal process necessarily of getting it published on the PyHC website. I'm not saying that that's not a good place to have stuff. It is. But, you know, maybe less formal demonstration of the capabilities is also desirable. And it's also a good way to track, you know, in terms of uptake within the community. If people are publishing for a certain package, then that's a big kudo for that package, isn't it? And finally, we really want to support open science. Open science can be defined a bunch of different ways. In the context of this presentation, I might define it as the ability to do reproducible and transparent science. And so, okay, great, we have shared instance. So I'd like to throw down a proposal here for collaboration between Helio Cloud and PyHC community. So first of all, it's our expectation and intention that sometime around the AGU meeting that we're going to create a new PyHC project for Helio Cloud. I'd like to rebrand it as Panhelio, but there's some entanglements there with that name that I have to sort out. But essentially, that would be in line with the Pangeo naming. And what this would be is essentially a container, and the Docker file and the software environment associated with it. And it, I would hope, might serve as a reference point for the PyHC community to do some integration testing, right? So we would deliver a working environment. And then once it's out there, then we would hope for pull requests from PyHC developers to basically say, hey, look, I've updated my package and the requirements are updated. I now need foobar 3 instead of foobar 2. And I've run the integration test. I've seen that the software environment will build. I'd like you to I'd make that official and put that in there, and we'd be very happy to do that. And then everybody has a shared software environment that they can refer to as a starting point for their development efforts, and make sure that we're not stepping on each other's toes, if you will. I'd like to propose that we make this a requirement for our core packages. These are our main packages in PyHC. These are the marquee ones that are heavily used in the community, and I think there's no excuse for them to not work or to be difficult to install by our community. We need to do this software engineering. I'm pretty hard-nosed about this, and I realize that some people may not like that statement, but I think at the end of the day, if we're really intentional about PyHC being for the community and working, we can't goof around here. We have to do real software engineering, and we have to do it with each other. It can't be silos of excellence as it's been up to this point. We need to start treating PyHC as a community effort in the sense of we work together, we compile together, right? And then I think optionally, perhaps, although I'm a strong advocate for it, is that we just create a CI/CD system that sort of picks up changes that get inserted in to this container software environment and just run it. It'd be desirable to have some integration tests provided by the core packages that we could then execute against it. And then that makes it even more goodness. And we don't have to have a very manual process of inserting changes. So we could just turn the development over to the community to do this. And then I think in support of open science, there's a real strong desire here to just publish an official release of this container and the associated software environment every year, right? Let's give it a DOI. And then people can target that, their downstream software, and say, hey, I use the 2022 software environment from PyHC to write my research code. And then they can reference that in their research paper. They can then publish against that, and they can put that in their build. And we have a much higher chance of people being able to reproduce and certainly rerun the software that's part of their research code, right? Because people don't have to fumble around with broken dependencies. And particularly if we're publishing the container, then we've got the container from 2022 that they are likely to be able to pick up and run locally. And so that even if their modern software system in 2025, say, no longer supports Python foo.bar, it's there in the container and runs in the container. Now, it's not totally bulletproof, but this does extend into the future quite a bit further than our current practice, which is, well, nothing. So, and then I'd like to also advocate very strongly that this community shift to using Conda Forge, and it really comes out of our difficulties with trying to engineer a common environment. Not having things on Conda Forge makes it harder to then figure out if things are only available through PyPy and some things are available on Conda Forge, that when we build in the Conda environment, we get nice cross-dependency checking, but then we have to individually insert the packages via Conda pip to get them in there, and it doesn't necessarily do the full due diligence, in my opinion, of the requirement checking. I still see things sometimes breaking. And I particularly find egregious the use of test PyPy to distribute your software. Don't do that. That's just bad practice. I'm just going to be not going to call any names out, but just don't do that. It makes it hard for the community to consume the software. It doesn't leave a good impression that you've spent your time to fully engineer things out, and it's hard to find unless you know about it, right? And so I think those are my motivations for that. And I think I'm going to stop there. I think that's my last slide. Yeah. Okay, so I don't know if there are any questions, but thank you for your time. I really appreciated the opportunity to give this presentation.
Thanks, Brian. Do we have a question or two for Brian before we move on?
Brian, I imagine you were trying to be provocative here, but I would say my usual thing is before we say anything is required, let's make it possible first.
Oh yeah, I agree with that. But I think it is possible. I know it's possible because I've already done it.
Well, or how about easy? Can we make these two things as goals first before we impose them as requirements? Let's try to make it happen and see where we go.
Oh yeah, definitely. I think we learn things as we go along. I agree with you there.
Because I like the idea of a central CI/CD. I think that's fantastic. I think Conda Forge is that's a really long conversation to be had because of course PyPy is still going to kind of be the place, but I think that's a long conversation.
Well, just to be clear, I'm not advocating removing PyPy. I'm saying that we have to have Conda Forge.
This ties nicely into what I'm talking about next with the PyHC gallery and then publishing Python packages with Conda and pip. So I'll keep this going in my next coming talks, but I have a couple of hands I'm seeing here, so I'm going to let you guys go before I say anything. I didn't see you put your hand up first. I apologize.
Michaela was first.
All right. Yeah, I'm pretty new to this community, and I gotta say, I do support, in theory, the transition to Conda Forge, and I know the argument about requiring it or suggesting it, that sort of can become a little sticky situation that I don't really want to get into. However, I tried putting my package on Conda Forge, and I'm looking at the contribution documentation, and it says that all the dependencies of your package must also be on Conda Forge. And so the issue I ran into is I don't have control over there's certain dependencies I just can't get rid of. And unless those are on Conda Forge, I'm out of luck. I can't put it on Conda Forge. So is there a way to mitigate that or go around it?
I think it's an excellent point, and it feeds right to what Jonathan was saying in terms of, yes, I'm being provocative, but I'm also a reasonable individual. Not that I have any power in this regard, but I would say, yes, we do need to experiment with this. And I think you've raised a very excellent point of why this might be a stumbling block. So it remains to be seen. We could create our own PyHC channel on Conda Forge and just host those things that are not currently on Conda there, just harvest them out of PyPy or wherever, and then insert them into our channel. So that might be one workaround for your problem.
Rebecca?
Yeah, my thought is to have this kind of project be something we focus on the spring and fall meetings as hackathons, but where we all attend and work on it. What's the thought there?
I'm a fan.
Works for me.
So we're a little running late, so we should probably go ahead and move on to the next set of presentations. But if you have any further questions, be sure to put them in the chat. And Brian, I think you do have a couple questions in there that haven't been answered out loud yet. Thank you again, Brian, for that excellent talk on HelioCloud. Sean, you're up next.
Yeah, sure thing. I was already going to blow through the Jupyter Book Gallery portion of this, so I'll make it all that much faster and really just talk about how it ties into what Brian was just saying, then I'll move on to the package publishing stuff. So I'm going to share this desktop. Hopefully you're looking at a Safari window with the PyHC website opened up at the moment.
Yep.
Wonderful. Cool. Well, yeah, so the first thing I'm talking about is a new version of the PyHC gallery. So I'll do that very quickly. So on the PyHC website here, you know, if you click the examples tab up here, this is what you get. It's a pretty small gallery. You know, we only have 6 examples in there at the moment. And this is a Sphinx site. I don't know if many of you have actually looked at the process for adding notebooks to this, but it's slightly cumbersome because while Jupyter notebooks get rendered on this gallery here, we're actually having to upload Python files in this like weirdly proprietary format to get it to come out this way. And it's not super ideal. So something that Ashley started, actually, I assume you're on this call here, Ashley. Yeah, I see you there. And something that I'm starting to make a hopefully real thing soon is re-implementing the gallery with JupyterBook. So JupyterBook, you know, same kind of technology stack as Jupyter notebooks, but they've got this book concept now, which kind of has like tables of contents and more book-like features. I've what I've done here kind of recreated what we had in the old version here in JupyterBook. So still the same grid up front. You can click and you can look at the gallery examples. But these are actually, if I look at the GitHub repo where this is stored, all of the examples are just regular notebooks. So from a very practical perspective, this would let people drop in their new examples just by taking notebooks they already have and giving it to us. So that's one leading motivator for getting this out there. I'm running this locally from a file right now, but I have a hackathon tomorrow actually, where we're gonna get this thing up live on the internet. Not to entirely replace this yet, but to get it in position to replace the old one. Now, how this ties into Brian's work there is these examples all have to work together. There needs to be one common environment that executes these things. So I've already kind of gone through and made sort of a minimal dependency environment that works for just these examples that we have right here. But as more people want to start adding more examples, we're going to need something closer to an environment that captures everything. So I'm sort of seeing this as playing along with the Helio Cloud initiative, where this is more focused on the pip side of things and Brian's work is more on the Conda side of things. So maybe they can complement each other. But the ultimate goal here is to figure out some kind of environment that works with all the packages such that anyone who wants to can just drop in a new example notebook. And then during the CI build for actually this deployment of this gallery website, we can be checking against like new versions of Python packages as PyHC packages update themselves and see if it breaks environments and then do things about it. So that'll be really helpful. And I don't know that I'm going to say anything more about that other than I'll just kind of point out the interface here. You can still run these on Binder. If I clicked here, you get like a Binder window where you could start executing stuff. If you go back, you also have Colab or this live code option that doesn't totally work yet, but ideally you'd be able to interact with the notebooks right here on the web page too. So new JupyterBook implementation of the gallery coming up soon, and it's also going to sort of necessitate more work on a PyHC environment and keeping that up to date. So these are all good directions to be going. I am also going to be opening up the next talk here on publishing Python packages, but in case there's anything to be said about the gallery, anyone want to jump in with a comment or a question before I just blow right past that?
Well, let's see.
Watching chat.
Oh, go ahead, Rebecca.
Sure. So Sean, for the Komodo tutorials that use big model data, we're going to have to link in from a CCMC resource. I'm not saying that Komodo can't be installed with everything else. That's definitely worth the effort. It's just the model data is big. How do you foresee doing that?
I don't have any good thoughts for you right now, to be perfectly honest, because
So-
this is notebooks hosted in a GitHub repo, and GitHub does have some ways to deal with large files, but hundreds of gigabytes like CCMC models tend to be, we don't have a good way to do that in an online gallery setting.
The thought off the top of my head is to figure out a way to have a link in this left column you're showing that would simply go to this other notebook hosted on CCMC resources.
Oh yeah, we already have a on the welcome page here. We've got links to project specific galleries. Like, SunPy already has a really well fleshed out example gallery, so making it easier for people to find that, for example. So there very well could be a Komodo one here where we just say, if you want to look at the Komodo examples.
Well, I was thinking like we have a Komodo PySat notebook that works using both of them. Something like that. We'll have to. Okay, we'll talk about that more after it's more solidified, I guess.
Let's see here. I saw in the chat just really quickly a question from Brett. There might have been one above it. I apologize, but this is the first one I saw and I have an answer to it. How are you going to ensure that updates to the environment from newer examples won't break examples that already exist? And that's actually going to be kind of a community participation thing. It's going to take work from both sides, both from people like me just guessing and checking at package versions to find compatible sets of versions, but also there's likely going to be cases where it's impossible to get every single package together in one place, or updating to a new version of a package would break old examples and things like that. And that's where we're going to need to come together as a community to identify where those problems are and work on them, basically like make a GitHub action, get the developers together to decide, hey, are you going to fold or am I going to fold on this package version? And anytime new package updates come out that would break things, we'll use it as a launching point to, say maybe even at a telecon. Should we even release this update yet? Should we ask this package to implement this differently, etc.? So it's going to have to be a collaborative thing.
You did have one more question in the chat further up from John. Do these have to be binary notebooks, or is GP text read the docs supported?
I would actually have to ask Ashley. I don't know if you know the answer to that question. I don't know it off the top of my head.
Yeah, I mean, I think it should be technically possible to switch to it, but there may be some sort of edge cases with how it interacts with the Jupyter book and the Jupyter hub. Like when you click that launch button, it's just going to pull that repo into the Jupyter hub and try to connect to that notebook. And then that means the Jupyter hub needs to have GPText installed to, work with the Markdown notebooks nicely.
We should try that because we did set that as one of our standards 4 years ago.
Well, so the way that I solve this is to have a pre-commit action that scrubs the binary output, the output cells from the notebooks. So then they're sort of they're just binary, but I mean they're just the JSON representation, but without those outputs. So it's cleaner, but it's a bit more. You need some CI steps in there to do it in that way. So I'm not sure like what the solution is, whether to go down that route. I mean, that's what they do, I think, within the project Pythia notebooks that I just linked, rather than using GPText.
Cool. Yeah, it's we don't need to solve it right here, but it'd be good to look into.
Yeah.
Yep. Cool.
Awesome.
Well, for the sake of time, I have to move on here. About 11 minutes into the time slot of talking about publishing Python packages, but that's okay because I've also practiced getting through this one somewhat quicker too. So
Don't feel the need to rush too much. Sandy did tell me we could cut a few minutes into their time.
Good. Then I'll take this at a more regular pace. But yeah, I guess no sense in delaying it anymore, so I'll go ahead and change gears over to that. So okay, so cleaning up my brain here. This is a talk that me and Ashley put together about publishing Python packages, which is something that's obviously good to know about when we're a community of developers here releasing Python packages. We put this together covering pip and conda things. I'm gonna be covering the pip stuff first, and I might have a little bit more slides than the back half of this talk where Ashley is talking about Conda Forge things. So maybe that can be more of a discussion based off of the demos and things we see from Ashley. But for anyone who was looking at Brian's ask in his last talk to consider publishing your package to Conda if it is on pip now, but not Conda, stay tuned, because by the end of this, you will have learned how to do that. And if you haven't published a Python package at all, but you've got some code that you're thinking about packaging, this is the talk for you too. I want to point out the resources that we got this info from real quick before I move into it, because they're really great. The PyPA is the default authority here on the left. You know, Python has its own documentation on all of this stuff, obviously. But there's this PyPackages project here in the middle, this little Jupyter book that was a lot more friendly than the default documentation, and I found it a lot easier to understand. And I actually learned quite a bit about publishing packages while putting this together. So even if you've been doing this stuff for a long time, you can forget some basics. It's good to check up on it. When we'll see a tool from this scikit hep group here when we get to Ashley's demo. But I recommend checking out their group. They're cool because they're like PyHC, but for high energy physics. And they've actually got some really good documentation and even some like command line tools for this stuff. So yep, there's resources. But yeah, I'm going to talk about kind of what a Python package is before I talk about what publishing them looks like. You know, we're going to walk before we run here. So conceptually, a Python package makes your code portable. That's probably not news to most people. Lets you install it with things like pip install. I'm sure we've all pip installed at least one command. You have package configuration inside packages that say things like what dependencies there are for the package and what package version this is. So packages can give you some info up front about who they are and what they work with. I'm also, yes, thank you, Ashley. Ashley put a link to the slides in the chat if you want to follow along that way. We put tests and documentation in good Python repos, and you can get it in some packages, but it's important to note that depending on how it's packaged up, tests and documentation are sometimes thrown out. So it's not essential for a Python package to have tests and documentation, but it is good to have them. Moving on here, we'll kind of to zoom in on this little diagram to the right of a Python repo. First of all, you know, it's good to have some package documentation here in your repo, like a README and contributing guide and all that stuff. We actually suggest a lot of this stuff in the PyHC standards. But then where you start to get packagey and not just Python repo code is with a package config file. We're pointing to this pyproject.toml file here. If you haven't seen that one before, you've probably seen a setup.py file. They all kind of do the same stuff. The metadata about the project is stored in these. Then you've got your actual package code with this init.py file, which is actually what tells things that this is a Python package and makes it importable. It can just be an empty file named init.py with these underscores, or you can have a whole bunch of initialization code in it. Like if you bust open NumPy's init file, you know, it's huge and they do a lot of stuff. But something I did learn actually while I was doing this, and I'll point out to you, is people who make guides for this stuff recommend that you put your source code inside of a source dir like this. We kind of have a mixture of that across PyHC packages. Some of them just put the Python files right there in the root directory. Some of them have more of a nesting structure like this. And it's actually good practice to kind of nest it inside of a source directory like this, because it makes it easier to separate local versions of your code from installed versions. So for example, if you've pip installed your own package on your machine, and then you're in the root dir of your package repo and you want to like run your test code, for example, like PyTest. If you have all of your source code files in the same root directory, it can get confusing as to whether or not you're testing against your local files or the installed binaries on your machine. They won't get picked up if they're nested like this, so people just say it's good practice to keep them nested to keep that better separated and to make stuff more sane. So consider doing that in your repos. So that's what sort of a package is looking like here. Pip is the main way that we work with Python packages. We've all seen it at least once, and this is by design in the Python language. If you didn't know, pip actually stands for Preferred Installer Program. So it is the preferred installer program for Python. It publishes packages to the Python package index, this pypi.org. And just some quick tips before we move on is that you can install things locally. If you haven't seen that before, you can do pip install dot, or you can do that with this -e flag to install it in an editable mode, which is particularly helpful during package development. So you can change your own package files on the fly without having to reinstall things. Or you can install from a GitHub repo with this pip install git plus URL syntax. We'll also see this in the demo that Ashley's going to do later up, so I won't dwell on this, but there is this pipx thing, which allows you to install Python packages as kind of command line applications so that you can run them like standalone. We've got this example here of using Flit, which is like a packaging and publishing tool. Ashley has to set up on his machine where he can just run Flit commands without having to say Python 3 Flit or anything like that. So yes, wheels. The one conceptually important thing about packaging up pip packages here is you get wheels when you package them, and those are like binary distributions of your Python code. So if you actually look at PyPI, like I've got Vera's client up here in the top right, you'll see a source distribution and a built distribution, where the source is just the Python files, packaged up in a tarball. And then you have the built distributions, which are your binary wheels. They're smaller in file size because they're a better packaged up representation of the binary. And it's just easier for pip to ingest, which is why it always looks for a wheel anytime you go to a pip install something. And for a package like Vera's client, where it's pure Python code, you can have what's called a universal wheel, which is just one wheel that'll work on any machine, doesn't matter what operating system or architecture. But for more complicated packages like SunPy, if you have more than just Python code in there, you've got to have wheels for all the different operating systems and CPU architectures that it might be running on. So that's an argument for keeping packages simple, but there's a way to handle it when they're not. Now, if you actually want to publish the stuff, okay, here's where we start to get into practical information. I kind of have this diagram here that sort of just shows you what it looks like. You're going to start off with a config file that will have your package metadata somehow. That gets consumed by a packaging tool, which outputs the package itself, and then you use a publishing tool to stick it in PyPI. Now, some tools are just a packaging tool or just a publishing tool, like setup tools and Twine is a popular tag team for doing this stuff. And if you've been doing Python for a while, that's the one you've probably seen. And then newer tools are starting to come out that modernize the stack a little bit, like Flit and Poetry, that are both packaging and publishing tools, and sometimes even environment managers and fancier things. So I'll show you what all this looks like, and you can start to see what it'll look like to actually stick your package online. Starting with preparing your repo for packaging, this is just getting a good repo structure going with all the different files we talked about a second ago. And zooming in on these config files here, here's a setup.py file on the left. And this is where you actually say what the name of your Python package is, what version it is, who authored it, the description, all that good stuff. You stick all that in metadata inside this file. Setup.config is another way that you can do this stuff, and you might have even seen both inside the same repo. They can store the same information just in different formats. But this is actually an old way of doing things now. There's this issue with setup.py being a Python file itself. It's an executable file, which means you have to execute it, but you can't do that without knowing the dependencies needed to execute the thing. So there's this chicken and egg problem, and that gets solved by using a more modern format like this pyproject.toml file. As of PEP 517 and 18, people are suggesting you use the toml format to describe your packages, because pip actually understands how to ingest all of this and can read the dependencies and know everything it's needed to set it up front with no chicken and egg issues. So yeah, sort of this older, more full-featured but complex way of doing things with setup tools and a separate publishing tool like Twine, and then a more modern, simplified way of doing things that really only works on pure Python stuff. I'm going to show you the setup tools half of this, and then I'm going to turn it over to Ashley, who's going to show you publishing with Flit and take it into the content part of the talk. So very, very few slides left here, just showing you what the actual commands you would run in the terminal are. If you're doing this with setup tools and Twine, you're going to want those packages plus wheel. So it's a good idea to pip install upgrade before you do any of this stuff. Make sure you have the latest versions. And then if you run Python setup.py sdist bdist _wheel, that inside your repo, it's going to get you this build folder. It's going to get you an egg info folder, and you're going to get this dist folder with a tarball and a wheel file. And this is basically your package right there. What it generates inside this dist folder is what you'll end up uploading. And you can just upload that straight to PyPI right at this stage, but there is a test PyPI that's managed by Python itself, and it's a good idea to specify test PyPI as your first repository to upload to, because then you can go and install it yourself and kind of check it out locally and make sure it's satisfactory. And once it is, then you run Twine, upload, and then point it to the stuff in your dist folder, and it just appears there. Boom. I think at this point, Ashley, I'm about ready to turn it over to you to show what this looks like.
Sure.
Flit.
If you want to unshare, and I'll take over. Yep.
Yep. I'm noticing we have about 5 minutes left in our initial time slot, but Sandy said that we can go a little bit over. So thank you, Sandy, for allowing that.
Yeah, so Flit. So yeah, just to reiterate, there's this pyproject.toml, which is more like is now kind of Python standard for how build tools should interact with your metadata. So, you write that, and then it gets consumed by one of a number of different build tools, and you could choose which one you want. So I'm going to show how flits is kind of the simplest possible one that gets rid of a lot of the complication that is inherited with setup tools. So yeah, so the oops, there we go. Yeah, so here's kind of the simplest possible package. There's an init file, and it just prints out this message, and there's a version string, right? And then if you type flit init, then it just generates, asks you a few questions, and generates the PyProject TOML file, so you don't have to write it manually. That's the minimal PyProject file you can have there. And then, you know, the next thing you want to add to that is dependencies. So you would just add another section within this project section called dependencies and list them in there. And then, yeah, then when you run flit build, that generates the wheel in a similar way that the setup tools did. And then once you've got that wheel, you could even test that locally just by installing that directly. And so I've got an example of doing that, and then you can see that my package is now installed, and I run the import, and it's functioning, you know, in its installed state. And then, you know, the next thing, you just run flit publish, and it will see that wheel there and the source file and the wheel. Yeah, that's the source file there, the sdist, and there's the bdist, or just dist here, is the wheel, and it uploads it to PyPI. So that's an example of using flit, but there's sort of a whole family of build backends that you can use, and you can go to the PyPA, pypa.io to have a look at the comparison between some of them. Another interesting one is this hatch system that's does more than flits can, but haven't really delved into that. Yeah, just briefly, I want to also mention this CI build wheel, which is also a recommended tool from PyPA, which helps you in building all the different binary wheels you need for different platforms on CI. So it provides some, you know, configuration on GitHub Actions or other CI systems to run all those build commands and to upload it to PyPI from that. So that's something that you know, people packaging you know, these complex Python projects that have binary components, and then you want to look into using that as the current state of the art. But there's a series of other, you know, issues with packaging that you could talk about here. But yeah, I would recommend looking at these sites, as Sean already mentioned, this scikit-hep that gives a lot of information about that. But next, I'm going to demonstrate this cookie cutter recipe that helps you to set up a lot of stuff related to these issues, right? So I'm just going to show a video of running it, but yeah, mentioning pipx again, you know, this is a tool you can install with apt or brew, and you can even just do it in your Conda environment. But it means that then when you run pipx run, then the, you know, cookie cutter is a project that's been downloaded from PyPI, but when you do it in this way, it won't contaminate your other Python environments. So it sort of does it in a self-contained way. So we're going to cookie cutter pulls in some dependencies itself, and you don't want that to be touching your other tools. So that's why it's useful for running these command line tools. And that's just the pointing to the cookie recipe there. So here's the video. So yeah, you run your pipx run, and that goes off and acquires the tool. And then again, you just answer some questions about your package. This is something, yeah. Oh, so here I select the flit tool, but it has the recipes set up using other build tools as you choose. Then once you've got that, then you see it generates a whole load of boilerplate things. And the main one that we're talking about here is this PyProject file. So that's where you see the build system choice and all this other stuff in there, right? So it does set up a lot of things which you may not want or might not want them straight away. So, what I would recommend, if you're looking at overhauling your current Python project, you can run through this and have a look at their documentation to see all the things that they set up to help you with your development. And then pick and choose what you want to add to your project. Or if you're starting a new project, you can use this right away to set up the project, but maybe throw away some of the things that are more complicated. Like it includes a lot of, so here's another tool called Nox, which helps to set up isolated environments for running different things like the tests and the documentation. So say, yeah, like this one here, it's installing using the docs option there that includes things like Sphinx and so on, which they're dependencies for building your documentation, but they're not dependencies for the package itself that you're distributing. I'm going to skip over that because it goes into more complicated things. So you can have a look at that in your own time if you're interested, because I really want to get on to talking about Conda Forge. So I'm going to demonstrate this with putting the Varus client pip package onto Conda Forge. So this is something I did in the last couple of weeks to prepare for this talk. So it was also a good motivation to get that to happen. So as Brian was mentioning earlier, we really need Conda packages for Helio Cloud. And it's basically because Conda and pip don't talk to each other, and Conda solves the dependencies in a more sophisticated way. So this is where we need the core packages to be publishing on Conda Forge, and sort of as many as possible of the other packages as well. So just to disambiguate here, so Conda is the command line tool for managing Conda environments. It does the environment solving to pull in all the dependencies for a particular project you're installing. It's created by the Anaconda company, and they maintain their own channel called Anaconda. So this is a collection of Python packages that Anaconda sort of validates. That we're talking about Conda Forge, which is the community maintains channel. So you can choose which channel you install from, and generally you want to be installing pretty much exclusively from Conda Forge, because this is going to give you a more consistent environment. I also want to advertise this Mamba, which is a drop-in replacement for Conda. You can install Mamba into your Conda-based environment, and it works exactly the same as Conda in terms of the interface, but it's a lot faster. And just to complicate this a little bit further, there's another thing called Mamba Forge, which is simply a distribution of a Conda installer with Mamba in the base environment and with Conda Forge configured as the only channel. So it's just to get an installation quickly. Mamba Forge is a nice little way to do that. Yeah, so Conda Forge packages work very differently from PyPI. With PyPI, you are building the package yourself and uploading it directly to PyPI yourself. You could do that on your local machine, or you could do it in the CI on GitHub Actions or something. But with Conda Forge, it's all, you need to contribute a recipe, and then that recipe will be executed on the Conda Forge infrastructure, which is a whole collection of different systems all plugged together with lots of automation. So the way to do that is you need this meta.yaml file. And so this is to get that more quickly, you can use this Grayskull project. And there's even this website here that has as a tool you can use directly on the website to generate that recipe. So I actually did this whole Varus client publishing with Conda Forge. I set up the recipe all just through the web interfaces. So once you've got that meta.yaml, you go to this repository that's part of CondaForge organization, and you follow their instructions to open a pull request that adds the recipe that you have. So this recipe contains sort of instructions for CondaForge to pull your package from PyPI for a particular version, and build the distribution of it. So once that's done, and when you go through it, then you end up with your own repository under the CondaForge organization. And there's more automation within that to update it from PyPI as new versions get added to PyPI. So then at the end of this process, you're then in a position where you have one process that is updating your PyPI package. And once that's pushed to PyPI, CondaForge will see that and pull that package and then build the Conda package for you and publish it to the CondaForge channel. So I hope that's somewhat clear. It is quite a lot of different interacting components. So here's an example that I went to with the various clients. So I just went to that website, entered my project. It generates the recipe. Then I open the pull request on on the CondaForge channel, and follow their instructions. There's a load of automation that happens, and you may need to fix some things. It probably won't work straight away. And then, yeah, you go through that, and then eventually you'll get there, hopefully. And you can go and check that link there to see what I had to change. So in my case, just needed to add something about flit, and a few extra things. And also, there was a small issue with CDF-lib, so that delayed adding the package. So this sort of shows you the the downstream effects that poor packaging can have. And this was a simple fix, but it was yeah. So yeah, at the end of that, now I'm the maintainer of this new repository here. And yeah, that contains a whole lot of things that CondaForge needs to build this package. And there'll be a whole lot of automated PRs over time that keep that updated. And I think you're responsible for merging them. So yeah, as an example here, after a while, I released a new version on PyPI and an automated. This bot here opens this pull request to update the version string here. So that's updating the recipe, and then I just click to merge that. Okay, so that's the end result there. It worked, but there will be more complexities if your packaging is sort of not up to scratch, and also it will be a lot more complicated when you have compiled code in your package. So here's this summary here. Those links to that pypackages.org and scikit-hep, and use Grayscale to generate that Conda recipe. And that's kind of the best link there to look at for the details of going through this process. And again, I'm just echoing what Brian said here about, we need CondaForge for Helio Cloud. I think that's it. Yeah, thanks. I think we have 5 minutes for questions, right?
Yeah. Any questions, comments for Ashley or Sean? You can always also put your questions in the chat later, or also in our PyHC Slack space.
I'll just ask it out loud. Yeah. So people have mentioned, oh yeah, this wasn't in there, so I couldn't get mine in. I mean, we're going to face that, right? So how would we solve that? Are people open to, oh, hey, let me help you get your stuff in there, or can you fork it and put your own in? I mean, no, that's bad. But So
But
what do we do?
firstly, we need to go to the PyHC project list, identify which packages are most important to get on CondaForge first, and then, you know, go through the deeper levels to identify which dependencies need to be in there first. And I know that will be quite a long list of things to
Right.
get right, and it will take quite a while, so we need to prioritize somehow.
Start at the bottom, right? Because you can't put something in
Yeah.
until the other dependencies are there. And so, yeah, but then, yeah. But I mean, some of the projects we might not control, right? If people have pulled in the dependency for some other thing, hopefully not too obscure, but maybe it is obscure and then that's not in there. So, you know, what would we do then? Is it possible to wrap something in that's not on there, that is not in CondaForge? Could you somehow
I'm
include
not
it?
sure. I mean, I think you probably can technically build Conda packages that contain multiple projects, but I think that's not the way that things should be done.
It sounds dodgy. Yeah, so I don't know. Anyway, we'll have to figure that out, I guess. But anyway,
But I do think there needs to be sort of a specific task that's funded to go through this packaging problem, because a lot of the projects do need sort of help from outside, I think, to upgrade their packaging processes. And again, there's, you know, outside problems. You know, it's not a case of you just saying, I want to make my package available. It's the dependencies which are the first problem, and that can be a little bit outside your control.
right. Okay, Nabil is responding. Am I saying your name right, Nabil? But anyway, that he's done that for other projects.
Yeah, you don't need to be the maintainer of the PyPI package or to add recipes to CondaForge. I think CondaForge, the repository I mentioned, does actually have, you can open issues to kind of raise the issue that a certain package needs to be added.
I know, Rebecca, you have your hand up, but we do need to move on to our next presentation. Can you put your question in the chat? Cool, thank you. So last thing we have on the docket for today is a look into some PyHC cross project work. So we're going to be having a combo of people from SpacePy, SunPy, and Happy speak to us now.
So this really builds on what Ashley was talking about with needing to do some outside work to get things, to get packages to be able to do what they need to do. So briefly talk about what we built and lessons learned, and then we hope to get into some discussion on how to do adapters. So this was funded work by Jeremy, John, and myself for a few weeks each to build some adapters. So looking at the broad PyHC landscape, here are the core packages. And when you start looking at the core packages and their interoperability, you can see that they have different underlying file, data type, in and outs that they can use, as well as handling things like metadata. So the problem space of this was you work in one package, but you need to bring in capabilities from another package, or you ingest data in one package, but actually do your work in a second package. How do you get the packages to talk to each other? So for this particular grant, we started with 3 packages, SunPy, Happy, and SpacePy, and made data adapters to work between the 3 of them. So SunPy can do images and time series, Happy does time series, SpacePy can do image and time series. So that was our landscape for building from adapters, so that if you have an instantiated object, you can bring it in. Some simple rules that we had to make effective adapters. We wanted to avoid cross imports and circular dependency. So if the Happy package has something to use SunPy objects, it should not require an import SunPy, because that would lead to the SunPy then needing the import happy, and the landscape becomes very confused. So these adapters were from a package to another, so they'd exist within the main package class, not as a separate repo that you create. And we had to include test scripts, and they has to survive loop testing. So if you do from SunPy to happy and then from happy to SunPy, you should get your data back. And Rebecca notes Komodo returns data in numpy arrays, which makes an adapter not necessary. Save that because we want to bring that up in the discussion of, is numpy and pandas sufficient? So here are the packages that we made to release, where it says in the ND cube library, it's actually in the SunPy library, then in the SpacePy library, and in the Happy library. So we're going to briefly cover each of the packages. So here you have some input data that's pre-baked into SunPy, goes X-ray flux test data. And in SunPy, it's pretty easy to create. You get the time series, and there's a peak routine for plotting, which led to one of the first lessons learned. Not every package has an automatic way to plot their data. And I just tossed that out to the community as figuring out, should there be an easy way in every package to plot, or should people just go to matplotlib on the outside? So time series to SpacePy space data. The key here is that space data objects require specific metadata in order to be viable. And SunPy uses FITS-derived keywords for its sample data sets with no guarantee that user-made data sets would contain FITS. So here we've created, if you look at the tree of the space data object, it has the epoch, aka the time, and the two channels, from the previous mentioned data. So technically valid. The metadata became an interesting puzzle. SpacePy uses less metadata than say a FITS-derived SunPy object would contain. It really just needs to have an ID and units. And SunPy defaults using AstroPy units. SpacePy does not default to having AstroPy units. What do I do with the extra metadata? Shoved it in as a dictionary into the global attributes for the space data object. So technically all the data transfers. Will it go back seamlessly? Metadata is a problem. I'm just going to put that out there. Likewise, NDCube. NDCube is an image plus a world coordinate system. SunPy uses WCS transforms. SpacePy does not have a native WCS system. It doesn't import AstroPy for that. So if you want to use just the image, going from SunPy to SpacePy, you can. If you want to use the WCS, well, you have to import the outside package AstroPy. Again, raising the issue, should there be certain standards that we converge on? It may not be bad to say, let's use AstroPy units. Let's not reinvent WCS. For Happy time series only, pretty straightforward. SunPy time series to Happy. Happy expects CSV or JSON ordered data. CSV is the default with very minimal set of parameters required. You can see what's required here. Start date, stop date, name of the data, each data item, its type, float, int, string, etc., units, and a descriptive field. So relatively straightforward to create and adapt. So here you see Happy metadata from a SunPy, from the Ghost twin plot of XRSB, XRSA, and it is created. Now, developer thing that I found doing this, one of the traps, why you have to fund people and this isn't automatic. SunPy says, oh, do not use .data when you're extracting from a SunPy object. Use toDataFrame. But if you use toDataFrame, it doesn't work in this. And if you go start chasing through the issues, you find out that they may be deprecating toDataFrame or they may be boosting it, but it is a known problem. So a lot of doing adapters was a big learning curve in order to try to figure out the package that you're trying to get from and the one that you're trying to get into. And there will be a fragility. Any adapter we make survives at the whim of future package updates. So that's why we had the mandate that our adapters will be in the core package, and therefore the responsibility of that package to maintain, rather than making it as an external routine, which would then be brittle and have to track in dependencies. In my particular case, doing the SunPy, I still have to do the round trip tests. Why? Well, we had to make all of these before we could do our round trip tests. It is temporarily in a GitHub repository, but we will be making it available in the official SunPy repository. So I would say wait for an announcement on the PyHC list for when these officially get released. Given the grant money ends at the end of December, hey, that's a good deadline to look for this. And of course, future support will be submit tickets to SunPy, not submit tickets to Sandy Freelance Pi adapters. So that will be going away. And also, hey, if you're interested in this, do some coding for SunPy to implement features you need. Just a little shameless plug there. All right, in order for speed and clarity, I'm going to continue with the other two package maintainers, and you can hit them up for questions in chat or after. For Happy is a very simple, straightforward protocol for moving time series data. You can fetch the catalog. You can fetch data item metadata specifically as a separate JSON object, and then you can actually get the data as well. So the metadata and the data are available as separate calls. There's a list of existing Happy servers that's updated. There's a Python client for connecting to Happy servers. So Happy is not a Python thing. Happy is available and supported in Java, in Python, in other formats. Happy is a spec. But in this case, we worked on the Python client, which people commonly use to connect to Happy servers. In this case, it takes data from Happy and puts it into SunPy and SpacePy. So here you can see, again, very straightforward. You give a server, a data set, start, stop, and the parameter or parameters you wish to face. And that's your standard Happy ease for how you specify what data set to fetch. You do a call to the Happy client. And in this case, to convert it to space data, it's a CDF. Because CDF is one of the internal representations that SpacePy uses. Does the data look well-formed and sensible? Well, time range, valid columns, and the required metadata gets populated in. Now, again, is there a standard set of metadata? There is for Happy. There is not for SunPy. There is not for SpacePy. So the metadata conversion is always going to be something to be cognizant of, the lack of no standard metadata. This code temporarily lives in Jeremy's GitHub area and can be peeked at there. His unit tests provide 95% coverage as well as examples. And the key, is to have test cases and examples as well provided to the community. And of course, this will be checked into SunPy and SpacePy for final delivery. Bonus results. One ancillary goal of these proposals was to cross-train us as developers in the other packages so that we can hopefully do further work in those packages. So to get started on this, Jeremy wrote a converter to CDF, and also has been looking at URI templates and doing a library for that, and then handling the system. So if the idea of this particular project goes, especially for you that work in CDF type space, let Jeremy know if you are interested, as he points out, in helping to mature this new facility. So spin-offs arise when you do any kind of adapter thing, when you say, I know I'm supposed to do X, but it would also be nice to do Y. Happy is an evolving spec. 3.1 is just about to release. 3.1 improves the way to describe channels in the metadata and allows an extension there. So thinking about how to do that is going to be an issue with the adapter. Again, this plays into how adapters are always going to they have to be part of a core project, so they're not always lagging within the spec. Likewise, doing spectrograms in SunPy, where do the Y channel labels go as a metadata that could then be used by sunpy.peak? Will people use this? How to specify missing values. Happy lets you specify a fill. So if there's missing data, it uses the specific fill value that you give. These kinds of data nuances show up in adapting, and really all you can do is document and move on at that point. And then John Niehoff did work with the SpacePy data model. Well, sorry, he made SpacePy, you all know that. And so he was doing the from SpacePy to other packages, from SpacePy to Happy, from SpacePy to SunPy. So their main data type is the space data, which is a dictionary-like container. And then there's also the DM array, which is a more array-like. Both contain a field called attrs, which stores metadata attributes. And space data are interesting in that space data can actually contain other space data. So you can have nested or tree-like architectures, which gives it a lot of flexibility and power. And then DM arrays, the underlying structure there is NumPy arrays. Going back to Rebecca's earlier comment about, hey, if you just, Komodo just stores everything as NumPy arrays. Knowing that something is stored in NumPy or stored in pandas could be very fruitful terrain to mine for future adapters. That's one of the things we'd like to talk about when we get to the discussions. So SpacePy is agnostic to metadata interpretation. It doesn't have a metadata required standard other than the minimum to define the data set. And it does have to and from CDF and HDF5, as well as from NetCDF3 and to and from NetCDF4, as well as JSON. So, let's see. So ISTP and SPDF metadata. Again, SpacePy uses CDF as very similar. CDF and space data inside are very similar. And John could possibly talk or in the chat about considering the switch the internal model entirely to CDF. But it does allow you to give support arrays, classic ones being uncertainties and also dependencies. So in SpacePy, the explicit ISTP, there's really nothing different happening with the base behavior data storage. It's just adding methods that make these connections through those attributes, which means that this can be extended to directly support CDF files instead of requiring that you go through space data to CDF. And the plot shown here is a direct plot from PSP fields data with no tweaking. Heard either a squeak or a yawn, hopefully a squeak. So looking at doing time series, so going to SunPy time series from space data. The generic time series already has a CDF reader, but it's pretty much a one-liner to do the conversion. And again, you can see the data is there. The data is valid. A lot of these were not hard in terms of implementation or lines of code. They were hard in terms of understanding what the underlying data model is that you're trying to deal with. So really learning curves were one of the big issues. For the time series implementation, in this case, again, build a data frame. The rest is details. Units are a metadata that, again, some people use the AstroPy standard and some just inherit the units, whatever they are, and rely on the user end to deal with it. Note it's limited for time series to scalar or 1D data sets. A 3-component time history of a magnetic field is still 1D because all 3 components count as one dimension. So if you have your X, Y, and Z of your B field, that would still count as a 1D versus 2D being a spectrogram or similar. The implementation located currently at his personal fork. And he notes that he's sticking with the principle of open dev and the workflow we've adapted. So the code is in his personal SunPy fork. And then there's open discussion available as well. And then obviously we will do the push requests once we complete our end-to-end testing and iron out those last few bugs and go to AGU. Going for ND-cube from space data. The native space data plot here is on the left and the ND-cube is on the right. In this case, he's assuming square pixels and linear color bars for the transition. It's a good illustrator of the disconnect when different things are meant to be generic, but are developed with other applications in mind. It's clearly not optimized for flux data. I like Rebecca's suggestion to have a hackathon for tomorrow, how to write a cross-package adapter. I don't know if we can get that in the schedule, but yeah, Rebecca, you and Julie should talk and figure out how people can do that. And going with the ND-cube implementation, you can see the details there. It passes the NumPy array directly. So again, if you know the data is a NumPy array and you're going to a package that stores the data as NumPy arrays, they become a least common denominator. It builds the WCS from timetable coordinates and quantity table coordinates. But again, not obvious. WCS, world coordinate systems, are their own object space that needs to be considered. And again, the test, as with the other ones, is using the existing sample test cases that tend to already exist in the test suite. This would go into advice for doing an adapter is take the test cases, see if your test cases that are already being tested against work in the adapter space. Complicated and corner cases exist. Ideally, as SpacePy updates, more cases can be supported without changing the underlying code. And that again goes to, do you have the base data representation, that which point updates are generally going to be for better parsing of metadata. And for ND-cube, we'll go up to any dimension. So he's still working on tweaks with that. So where's the implementation? As with SunPy time series, use different names for the branches, but there's a personal fork of the ND-cube branch with a push request coming soon. And you can do discussion. There's open discussion at SpacePy. And you can also reach out to him as well. So lessons learned, among the lessons learned, examining the code. So we were doing from a package. So I was doing from SunPy, John was doing from SpacePy, Jeremy was doing from Happy. It made us look at our internal data models with sort of fresh eyes now that we had to adapt our data models to other systems, and can lead to improvements, or at least considering ways that your internal data model might be made either better, more efficient based on looking at the other packages, or at least more interoperable. It was very time consuming and difficult to get your head around the alien package that you were trying to adapt from. The idea was each of us knew the from package, but were relatively novices on the package we were going to. So we had to understand other people's data representation as well as what their code style is. And since our adapters are going to live in those foreign packages, we had to make sure that we were writing code that was within the style and expectations of how those packages do things. Specific notes, SunPy docs are pretty good for running tests. And I completely agree that the SunPy test suite is one of the stronger ones with good test data baked in. SunPy linking to the AstroPy contribution doc was nice, so that you were aware that that package is required by SunPy and what it provides. So John noticed this is something to work on with SpacePy, improving the documentation, because you really learn about documentation when you have to play in someone else's space, even more than when you're using it. We accepted that the first round converters will not handle 100% of cases, and that the user community must support, which is fairly standard for open development in any case. A lot of this was getting something that works, because again, we were only funded for a few weeks. So it's less about having a single standard model and being adaptive and saying, what's a good model that works for time series? What's a good model that works for image data? What's a good model for metadata, for WCS? And it raises the issue of, what are pathways to converge on having more compatible data models? And so we're actually going to go right into the first discussion question, and there is a Miro board for this. So we decided to do the discussion in the form of tossing out provocative questions as bait and then see what people think. So there's a link in the chat to the Miro board. If you haven't used Miro, you can zoom out and see the whole board. You can zoom in and see the board. You don't need an account to use it. It's free. And you can start to fill in advantages and disadvantages. We are using a Miro board because we want everyone to be able to talk in this particular matter. Since we have 26 participants without the rush for microphone sharing. And then after we've done the Miro board, we'll pull back for a recap. But the first question for future adapters, should we keep going with each package writing their own converters? Or should there be a one ring to rule them all external conversion package? Should we just mandate packages must use a standard data model? You must use CDF internally. You must use AstroPy units. You must use Happy for time series. Or should we focus on APIs and the interfaces and come up with standard and common APIs and let packages keep their internal data model? Or should we just expose the NumPy or Pandas arrays in an accessible format and say that's good enough? As long as you can sling NumPy arrays around, you are good to go. So people are commenting there. We actually have 4 discussion questions. This one is the primary one. So John has his hand up, so I'll ask him first.
Well, I just wanted to point out our kind of provocative version of this question, which we kind of toned down on the Miro board, but it's like, well, should it be the business of PyHC or anybody to say there should be one internal data model that everybody has to adapt to? What do people think about that? Is that what we should do? Or the alternative approach or some of these other things of just, building more connectors, adapters? Because the adapters are a lot of work and they have to be maintained, but so is the massive, huge data model. So, not massive, but complex, trying to get everybody to agree on data model.
So, sorry, just as a practical note, folks, I'm seeing people type directly into the cells. If you grab a sticky note off of that left-hand side and put the sticky note on the cell, it's going to make it a little bit easier to have multiple people put stuff in the same cell.
So for those not in the Miro board, here's the Miro board. And Jonathan Niehoff, can you demonstrate grabbing a sticky note and putting it in a cell?
So on that, well, it's not showing the sticky note, so that'll help it. On the left-hand side there's the down arrow. Just click on the double down arrow in that in your side thing. Yep, there. And there should be something that really looks like a sticky note that shows up in there. If not, then click on the double over arrow. I must have added manually. There we go. It's like one of the first things on mine. So there we go, sticky note.
Stickers and emojis?
Sticky note.
Sticky
right
note.
Up there. Yep. I mean, or slap a text bar or whatever. It's just going straight into the in the cell. Makes it a little bit harder to put multiple things in there.
Okay. So one thing you can do that I've seen, can you just put some blank stickies in there for people to start writing?
Yeah, I'll make a little stack.
Yeah. 3 Post-its for everyone. I like no, just no. So John, there's your answer on the common data model.
Well,
should we mandate one data model? Because all data is the same in the end. It's just numbers. There's absolutely no difference between a spectrogram, a time series, a model.
Image of the sun, remote sensing
3D
data,
ionosphere.
Stream flow data.
Okay. The other issue, of course, is okay, one great data model. Which one? Well, mine, obviously.
Well,
Right.
Do we want to time box this and move on to the further questions? And people are obviously still thinking on this.
Let's go till 12:45 on this one.
Sounds
and then
good.
see where we're at. Yeah, Nabil says it's impossible considering the difference of data file each package has to deal with. That's a very good point. It raises the fact that it's not like packages get to choose the data formats that they're ingesting in the first place. If stereo is releasing FITS data and you want to support stereo, then you're stuck with the format that's, in the metadata that stereo has provided for that. And it's maybe completely different than, what SDO is using, and it'll definitely be different than what Supermag is using.
Sandy, you, when you were writing your stuff, you said something about storing the extra things that you didn't have a place for. And I mean, that's actually sort of important to think about. The really nice models that I've worked with have just a place where you could just dump additional data. Like in Happy, we've got additional metadata, and we can actually apply schemas to those metadata. So it's nice to have that sort of thing where you can just put all the other stuff so that when you want to get back to it, it's there, or it's just there for reference for a human to look at.
That's a good point. You should never throw away any metadata. Shouldn't be like, oh, this won't be useful, even if it's just something like the comment field from a FITS header. As long as it may be, it should be stuck away somewhere. I will assert that without proof. All right, we have 10 people active on the Miro board.
It's
That's
getting
pretty
really
good.
confusing with someone adding a bunch of rows and selecting everything. I can't follow this.
I'm getting dizzy.
Yeah, it's kind of like the stock market for ideas.
Yeah, if whoever grayed the whole thing out can manage to undo that, that would be great.
Do they know who did it? But they did.
I'm glad everyone's being ethical and not like deleting stickies that other people put that they disagree with. Should I have even suggested that? Probably not.
I didn't know you could do that.
And we're also monitoring the chat as well. So if you're more old school and you want to post in the chat or just steal the mic, feel free to speak up while this is going. Multi-channel is fine.
Is there anybody that seriously thinks there should be one data model for the entire set of PyHC packages? I mean, are you crazy?
Well,
I know that's provocative, but really?
You're asking for trouble.
I'll answer that because I used to think that there would be, that it was possible to do that. And I think in part just doing this project, it kind of it's become more clear to me that it's really more just about adapters, that just everybody's got a model that's optimized for the particular workflows that they're doing. And what's important is that we just have ways that we can get back and forth between them. And I do kind of agree. It's impossible to have one model that would actually be satisfactory to everybody.
I mean, the only way you can have a single model is that if everybody's needs are met by that model, or the model is so basic that nobody's needs are met by it, and you just claim it. So the simplest model would be to have a data container with an open field that can take any object from text to a binary bit of data and just call it PyHC data and just wrap it. And you put a name on it, but effectively there's no information about what's in that container. And yeah, it'll work for everybody, but it won't work for everybody, right? Because you don't know what you're passing along other than some PyHC data. So, gee, wonderful. Thank you for not, no thank you. So the data model needs to have labels on what it's passing around. And if if I work with spectra, or you work with time series, or you work with images, we all have different metadata needs. And I see no reason to pack together the omnibus spectra, time series, image photometry, text analytics, literature search data object. I mean, this is ridiculous. And these things should be tailored to their use and their subcommunities.
Right, but like CDF continues to pick up more and more use cases, right? The edge cases are kind of like where they're trying to store images inside of a CDF. But maybe I agree, it probably doesn't do that very well. But I mean, there are a lot of things that you can get into that model once once a group is familiar with that model.
Yeah, but okay, take the image thing in CDF. I'm sure that works for some people, but speaking from the cloud point of view, being able to go through the tiles quickly and just pull back the piece that you want is not supported, and you want to use something like Parquet. And so for the software that's working in the cloud, which hint, hint, I feel strongly the PyHC community should consider as a set of requirements for their projects, but never mind that. I mean, the data model is too simple for that, to support that. So you need to use something else.
And it's not efficient. I mean, that's the first problem. It's just not very good at doing that use case, and really, what's the point if it's not that efficient? You better just have a reference to a CD.
So we've reached our 12:45 point here. I will well afterwards, hopefully before the end of the meeting, but probably shortly thereafter, we'll just try to capture what's in this board into sort of a summary document so people can kind of see that in a different form.
Yeah, that was one of the points of this effort, was to try and explore this question of, would that be feasible to try and have some kind of data model consolidation, or is the adapter approach still the best one? Or, then there comes the question of how many adapters, how much, at what level should you try to adapt things? So, because a lot of the examples that you quoted, oh, well, there's time series, there's spectral data. It's like, well, those are still time series. So you could have, and let's say it the other way. What if underneath all of these images and time series and remote sensing data and all that stuff, it was all stored in something HDF5, and all the tools were optimized to do either way with it? That actually would make things a lot easier. Right. So I think it's just too late for that.
Well, I think maybe it's never too late. It's just harder as things go on. And if there are existing models out there, then there should be positive pressure within the community to actually adopt and use them rather than reinvent yet another one. So if CDF is doing time series well, and it should be the conduit along with tailored, it's not just CDF, right? It's CDF plus the choice of the metadata.
Well, yeah, but see, by data model here, we got to clarify the terms. The data model really means that internal data structure inside your code that once you read a file, you bring it into this data model. So FITS is not a data model, but the thing that you stored it as when you loaded it into your program, that's what I was considering the data model.
Yeah, I agree with that.
Right, like a space pie is a data model.
Yeah, so
right, CDF doesn't matter. I mean,
or space data. Sorry, in space pie.
CDF, FITS, HDF5, HDF4. They're all serializations, choices in formatting to serialize the data model.
Those are data formats, not data models. The data model, in this sense, and these terms are overloaded, but yeah, that internal representation in your code, ideally, it's an API so that you could have different implementations.
So Rebecca brings up, Komodo deals with so many data formats, it's crazy in the chat. So you could almost say, Komodo deals with many data formats because they have to read the data, and the data is in those formats, so they have to ingest it. The opposite approach is Happy, where Happy says, if you provide your data in this format, anyone can easily access it.
So, I mean, Autoplot reads probably 20 or 30 different formats, and I've still been able to have one model that represents everything. So I think it's possible for a class of data that's similar to what would go into a CDF.
Shall we move on to the next question?
Sure. So, next question would be about metadata.
Yeah, so to see that on the board, if folks aren't familiar with Miro, you can drag with your right mouse button to move around.
Or you can use scroll bars.
Or you can use scroll bars.
And this is the very broad how to handle metadata. Is metadata translatable in a survivable way? Is there a universal standard? Should there be a universal standard? How many different ways should units be represented before people say there should be a standard for units?
Yeah, so if we do something like, oh, everybody should use AstroPi units, then suddenly everybody depends on AstroPi. And any dependencies that AstroPi Units has should be minimized and be very, very basic so that you don't end up with an exploding dependency tree.
But is AstroPi willing to maintain all the units that are out there that they haven't had to deal with in astronomy? You know,
Right, or
the
do
solar
they have-
physics units and all the space physics units.
Yeah, or do they
John?
have a plug-in mechanism? Oh, yeah. Was that Eric?
Yeah, isn't that going to be a problem as long as we have any dependency on an external package because we don't have control over it?
Yeah, so we
it's-
should only try to rely on external packages that have a what we would call a reasonable dependency structure underneath, right? That's a hard discipline to maintain, but it's important. We tried to
Nabil,
not make it worse with this project.
So Nabil, you said you can register your own units with AstroPi. Could you take the mic and comment on that briefly? I'm not familiar with that. Did that become part of AstroPi's then future distribution, or is it just a local portion?
For example, in SumPy, we needed a Maxwell unit, so I didn't add. There was a CDS unit that was missed for reasons because astronomers don't seem to use Maxwell, so we added it in SumPy, and it's as long as you import it somewhere in your code, it becomes registered, so someone can then just do operations with Maxwell units.
Right. So it fits within the structure of AstroPi because it's extensible, but it does mean you kind of pick up a SumPy dependency if you want to use
Well,
it.
if you want to use I mean, long story short, I've also PR'd it to AstroPi. AstroPi normally will allow you to add units. Just the issue, I needed to use it now, so I added it to SumPy. But then I also added it to AstroPi with the idea that when SumPy depends on the required version of AstroPi, I can then delete that code, which will be 5.0 for SumPy, I think. I need to double check.
You hit a key point with you needed it then also. So you're going to develop in the package,
but
Ashley mentioned there needs to be outside support often if you're going to develop in a foreign package. And we definitely found working in a foreign package takes way more time.
Wouldn't it be productive to have a very small package that is just the units?
I guess that's an answer. That's a question to ask the AstroPi people, because obviously there are several unit packages within the Pico ecosystem. Pint, the YT one, which I can never remember what it's called. Obviously AstroPi, and NumPy is slowly growing. NumPy is slowly growing support for units. So there is a larger question here whether or not just AstroPi, but the entire Python ecosystem can unify around one singular units package. The problem is that I think it's going to take time and money, but
so are they actually talking like units would propagate through operations? Is that the idea? Wow.
Yeah, so NumPy are adding D types for units, which will allow them to be propagated and added to arrays and propagate through operations.
Doesn't Plasma Pi already propagate units as well?
One of these systems does.
Yeah.
I mean, AstroPi units, I assume Plasma Pi's units and AstroPi units propagate their units through operations, but it's not through NumPy, whereas obviously NumPy will grow support for you to do this internally eventually.
So we've got 5 minutes left for 2 more questions here.
We also have one of them's a stretch question. We also have a comment, coordinate systems. That could be very useful as an external package.
Oh, that's a very large can of very wriggly worms.
Yeah.
You got to
We
boil
won't solve that now.
Everything's got to be boiled down to the simplest possible case.
Ensemble is pursuing funding for this. You don't have to boil it to the simplest case. You just have to get funding.
Coordinate systems, if you want a definitive definition of a coordinate system, that's hard. SPICE has done it. They have a framework for that, but it's even there's not definitive definitions because different instruments have different needs. I mean,
I think how big our packages are and what functionalities and what's packages is a different conversation to this as well.
Yeah, I think we're supposed to give some time back to Julie for the wrap up, right? So
yeah, we can do that now. The other ones were, how much support, how much time should developers do doing documentation versus focusing on coding? And the last one is becoming cloud aware, but we can save that for future meetings. So I do want to thank everyone for the time.
If
and
folks want to spend a few
comments
minutes,
by,
sorry,
Yeah,
if people want to spend a few minutes over the next day poking a few more things in there, that I'll leave that board up before we boil it down.
and we'll have a poster at AGU, and thank you for helping us create our poster with the Miro board, but we will actually be assimilating and summarizing what you all gave so that it can live on and continue the conversation. Back to you, Julie.
Well, that was a fun session. I like that. Let's do more of those in the future. Well, thanks everyone for making it today. The only real wrap up I have is to, remind y'all that tomorrow is a tutorial / hackathon day. We're going to start with a tutorial. I think Rebecca, maybe some others are leading that, writing a model reader for the redesigned CCMC Komodo structure. And then we'll have an hour-long hackathon session. So if there's an idea you would like to hack tomorrow, feel free to bring it and be prepared to work on it for an hour or so. I think that's all I got. Anyone else have any summary thoughts they'd like to throw out there?
I've got something real quick. I want everyone to take a look at their inbox after this meeting, and also the Slack channel if you're in there. I'm going to post a link to a short little poll. We're already starting to think about the 2024 solar eclipse. I don't know if anyone else's heads are already that far in the future, but PyHC is looking to hold some kind of in-person event at the eclipse one, because we're a sun researching group and it'd be a good group to experience it together. But it'll also give people a work reason to travel to see the eclipse, which I think is just dandy too. So quick little question about yes or no, would you consider attending something? And
Awesome.
Sandy, I left a message for you in the chat. I'm starting trouble.
or I started trouble.
I'm the youngest of 3. It's my job.
I am too.
Well, Sandy, would you be willing to advise creating a Komodo adapter tomorrow?
You're muted,
You're
Sandy.
muted.
God, I was done with the mic. Okay, yeah, I'd happily support. So I don't know, wouldn't be able to create one in time, but I'll happily support and advise with the Komodo one.
I got some work already done, so maybe.
And Komodo's
Awesome.
been, really big in the being able to handle anything thrown at it. Komodo and Autoplot are 2 really strong candidates for that.
If you're up, then Julie, you can write us down, and whoever shows up can help poke us along or kick us down the road. I don't know.
Sounds good to me.
If you did that later in the week, I'd be able to attend. And I'd like to.
Oh, like Thursday? Friday's
Yeah,
a holiday.
Friday'd be better for me.
What day did you say?
Friday. would be
It's a
better.
holiday.
Jeremy works all the time.
Friday's a
I'm
holiday.
officially on holiday,
Oh,
but
yeah. Thursday afternoon works.
okay.
Anything else? Oh, sorry, I'll let you finish. Sorry.
Julie, that's up to your schedule, or we could try to do this outside of the meeting. I'll put my email in the chat. How about that?
Let's start there.
Figure this out. Put me on an email.
Yeah, Thursday afternoon, at least Mountain Time, I have various meetings going on, so I'm not sure if I could personally be there, but this Zoom is certainly open for people to get together and collaborate if they want to work more on something like that.
So maybe we do this. Okay, so Sandy and Jeremy, do we want this as a hackathon tomorrow and poke Julie around, or do we want to do this offline?
Well, I said I'd support, so I will go with your executive decision on this.
Executive,
Notice what I
whatever.
did.
So Jeremy, you pick.
I just can't do tomorrow. I'm occupied.
All right, I'll send an email then. Can you email me, both of you? I
Sure.
don't have
I'll
your
send you an
email
email
address.
now. We can just-
All right, cool. Sorry to take recording time, Julie.
You're good.
Sorry. Okay, you'll email
Oh,
me.
this is great. Work outside of the meetings, exciting. All right, well, that wraps up today's fall meetings. So I'll see you all again, same time, same place tomorrow.
Yeah, you will. Thanks so
Bye.
much.
Thanks.